Have you ever wondered why your hair sticks up when you rub a balloon on it? Or maybe why you're more likely to shock someone in the wintertime? My name is Annalise, and this is an intro on everything you need to know about electrostatics, the study of charges. No, not those charges. The first thing you need to know, what are charges? Well, charges are tiny properties of particles like electrons and protons that cause them to interact with each other. And they come in two different types: positive, carried by protons, and negative, carried by electrons. And if they have the same number of protons and electrons, then the object is neutral. Now, how do these charges behave with each other? Well, opposites attract. Just like in 10 Things I Hate About You, Kat Strafford, the smart, strong-willed feminist, and Patrick Verona, the charming, stereotypical bad boy, are ultimately drawn together despite their clashing personalities. On the other hand, like charges will repel. But how do we know this? Fortunately, we can perform an experiment to prove just this. Here with me, I have two pieces of pre-prepared tape as well as some charge tape, my T-tape and my B-tape, with paper and foil. And so what I'm going to do is to lay my B-tape on the surface as well as my T-tape directly on top, and then pull the two up still stuck together. I rub the T-tape on the back of my hand until there's no attraction to myself, and I pull them right apart. Now what I'm interested in seeing is how these tapes react to other tapes or materials. So with my T-tape, you can see strong repulsion to another T-tape, attraction to the paper and foil, and a strong attraction to the B-tape. And with the B-tape, with other materials, there is a strong attraction to the T-tape, paper, and foil, but repulsion with the other B-tape. Why does this work? When I peel the T-tape off the B-tape, I'm pulling apart millions of microscopic charges, and some electrons or negative charges from the T-tape get transferred to the B-tape. This leaves the tapes with an imbalance of charge. The B-tape becomes negatively charged, and the T-tape becomes positively charged. Now, experiments like these created the triboelectric series, explaining why some materials are more likely to gain or lose electrons. We can see this in action with an electrophorus experiment. If I rub a styrofoam plate and plastic together, electrons will transfer from one material to the other. According to the triboelectric series, styrene is lower and will gain electrons, so the plate becomes negatively charged. It may be difficult to see, but when I touched the light bulb attached to the pizza pan, it lit up. As I bring the pizza pan near the T-tape and B-tape, it's attracted to the B-tape and repelled by the T-tape. Now when I touch the bulb again, it lights up. Watch how many times the cycle can run. As you can see in the diagram, the initial charge of the plate was neutral. The pizza pan itself is a conductor, so the electrons within the plate can move around. The electrons in the pan are repelled by the styrofoam's charge, so they move to the top of the surface to maximize distance, a phenomenon called polarization. When the light bulb lit up, the electrons from the pan were transferred through the wire to me, and the pan became relatively positive. Taking the pizza pan off the styrofoam, the bulb lit again when touched, causing electrons to flow from me back to the pan and become neutral again. The forces driving this current can be described by Coulomb's law, describing the amount of force between two charged particles at rest. It tells us that the force is stronger when charges are larger or closer together, and the force weakens rapidly as the distance increases. Thank you so much for listening. Now that you know the next time you get a shock, you'll know all about the hidden dance of charges.